Property 7, minus a to a fx dx is equal to twice of 0 to a fx dx if fx is even, and result will be 0 if fx is odd. Okay. So now let's prove it. Prove. Now minus a to a fx dx, this is can be written as now negative of a to 0 fx dx plus 0 to a fx dx. Now which property I have used here? A to b fx dx is equal to a to c fx dx plus c to b fx dx. Property 3. Now going only for this part, solving this part. Okay. Minus a to a fx dx. Now let x is equal to minus t, and differentiating what we are getting, dx is equal to minus dt. Now when x is equal to negative a, t is equal to a, when x is equal to 0, t is equal to 0. Okay. So now question becomes integration of a to 0 f minus t minus dt, and this becomes a to 0 negative of f minus t dt. Okay. Now this further becomes, we are having this as integration for 0 to a f minus t dt. Now using negative of f a to b fx dx is equal to b to a fx dx. Property 2, and further it becomes zero to a f minus x dx. A to b fx dx is equal to a to b fy dy. That is property number 1. Okay. Now in place of this part, what we can write it? We can write this part. Okay. So we can write it now, minus a to 0 f x dx is equal to 0 to a f minus x dx. It was negative of a, it is negative of a to 0. Negative of a to 0 fx dx, negative of a to 0 fx dx can be written as 0 to a f minus x dx. Now our question becomes, now what we have to prove it? It was minus a to a fx dx is equal to minus a to 0 fx dx plus 0 to a fx dx, and this can be further written as now this is equal to 0 to a f minus x dx plus 0 to a fx dx. Okay, this portion we have written in place of this one. Now case 1. Case 1, when fx is even function. When fx is even function. Now for even function, f minus x is equal to fx. Now minus a to a fx dx is equal to 0 to a fx plus 0 to a fx, and this is equal to twice of 0 to a fx dx 0 to a fx dx. Number 2, case 2, when fx is an odd function. When fx is an odd function. Now when let us write for odd function. For odd function, f minus x is equal to minus of fx. Okay, so what we are having now, minus a to a fx dx is equal to 0 to a, again here 0 to a negative of fx dx plus 0 to a positive of fx dx, this is equal to 0. Okay, so we have proved when fx is even function, when fx is even, result is this one. So this we have proved it. And when fx is odd, then result is 0, or let us write here, this is equal to 0. Okay, so we have gone through this part and we have gone through this part. Proved.